Hi friends, in this video we are going to solve this problem. It is given that y dy by dx is equals to x times y square by x square plus phi of y square by x square upon phi dash of y square by x square, where x is greater than 0, phi is greater than 0 and y of 1 is minus 1. Then we have to find the value of phi of y square by 4. You can see by looking at the option that value of phi of y square by 4 is in the terms of phi only. Okay, so that we have to keep in mind while getting the solution. So as we can see that it's a differential equation, it contains dy by dx, but the value of phi of y square by 4 is in terms of phi only. So it basically means that we have to solve this differential equation, which will help us to get the value of phi of y square by 4. Okay, so now let's start with the solution. So as by the observation you can see that it is a function of y by x. Okay, it's one of the standard way of solving a differential equation. If it is a function of y by x, we do the substitution like y by x is equals to v. Okay, you can just shift this x on the left hand side, so we get y by x, dy by dx is equals to y square by x square plus phi of y square by x square upon phi dash of y square by x square. Okay, so this is given. So now this, as I said, the substitution is let y by x is equals to v. So what we get, basically we get y is equals to xv. It's very important to know whenever you have a differential equation, what is your dependent and independent variable. So in this the above differential equation where y is dependent and your x is independent variable. So after this substitution, our v becomes the new dependent variable. Okay, our v becomes the new dependent variable. So the previous differential equation, the above differential equation, contains y is dependent and x is independent. So the new differential equation after the substitution will contain v as dependent and x is independent. Okay, so now let's substitute this in the above equation. So what we get v y by x is nothing but v d by dx of the value of y is xv. Okay, so now this is equals to, it's a y square by x square, plus, okay, so after the substitution it becomes v square. Okay, it becomes v square plus phi of v square upon phi dash of v square. So now let's simplify. So we get v bracket, we can apply u into v rule here. So x is going to be dv by dx plus v, the derivative of x will be 1. This is equals to v square plus phi of v square upon phi dash of v square. So now we can just multiply v inside. So we get xv dv by dx plus v square is equals to v square plus phi of v square upon phi dash of v square. You know, even by looking at the function phi upon phi dash, somewhere it reminds that we can use some formula of integration to get the answer. It's a one of the standard way. Okay, anyway, we will arrive to that. This v square will get cancelled. So now what we get v times, we can just simplify this, we can collect, I think we can collect v on one side and x on another side. So v of phi dash of v square upon phi of v square is equals to 1 by x. Now it's a dv by dx, so we keep a dv here and let's take dx inside. Okay, now we can do the integration from at both the side. So it's a phi v into phi dash of v square It's a v into phi dash of v square upon phi of v square dv is equals to, then 1 by x integration is going to be, okay, we can, let's do it on next step. Okay, so now, so the, if we see the denominator, it's a phi of v square. What's the derivative of the denominator? It's going to be phi dash of, the derivative of phi of v square is going to be phi dash of v square into derivative of v square by using chain rule, so it's going to be 2v. Okay, then it's going to be 2v. So as we can see that the denominator derivative can be adjusted in the numerator by multiplying and dividing by 2. So we get 1 by 2 times integration 2v phi of phi dash of v square upon phi of v square. Then it's a dv is equals to 1 by x integration is going to be log x. And since even on the left hand side, as we know that the answer is going to be log of the denominator, so we can write our constant as a log c. Okay, so then this is going to be 1 by 2 times 1 by 2 times log of the denominator, which is phi of v square. Okay, now this is equals to log x plus log c. So now what does this turns out to be? We can take 1 by 2 in the power of phi of v square by using logarithmic property. So it's a log of phi of v square. Okay, this raised to half is equals to log of cx. Okay, now we know that log is a 1 function. Okay, so we can drop the logarithm from both the sides since it's an injective. So if we drop that, what we are going to get? We are going to get phi of v square, and then this is equals to, is going to be c square x square. Okay, actually we are dropping the logarithm from both the sides, then we are doing squaring. I hope that's easy to understand. Then it's a phi of, what is v? It's a y by x, so it's a y square by x square. So this is equals to c square and x square. So we got the value of phi of y square by x square. Now we can use the initial condition to get the value of c. Okay, so what is the initial condition given? It is given that y of 1 is equals to minus 1. This is given. So now let's put y, x is equals to 1. So the value of y will be minus 1. Now let's put, I'll start from here. Put x is equals to 1. So we have y is equals to minus 1. Okay, so then what we get phi of the y value, y square, it's going to be again 1. So it's a 1 upon 1. It turns out to be 1 is equals to c square. Okay, so what is the value of, then what is the value of c? Okay, anyway, we require the value of c square because here we have c square term, it doesn't have c. So then what is the value of phi of y square by x square? So then what is the value of this? C square is nothing but phi of 1. It's a phi of 1 of x square. Now what we require? We require the value of phi of y square by 4. Okay, so it's very easy to understand that we have to substitute, put x is equals to 2. So now when we put x is equals to 2, we get phi of y square by 4 is equals to phi of 1, and then 2 square, it turns out to be 4. Okay, so the value of phi of y square by 4 is 4 times phi of 1. So we can say that option C is correct. Option C is correct.